one was basic probability, always thinking of it as in the long run, right? And then simulating a chance process with your calculator or table D. So let's get into some actual probability. So the sample space, what we call the sample space, sometimes it's labeled as S, of a chance process is the set of all possible outcomes. So just listing out your possible outcomes. So if we were talking about rolling a dice, your sample space would be the possible outcomes. So you would list them out. That's it. That's called a sample space. All right, you're going to see a lot of probability models. Okay, probability model is a description of some chance process that consists of two parts. It's usually a table, all right, that consists of both the sample space, meaning all your possible outcomes, and also the probability for each outcome. So a probability model will probably look something like this. X is your random variable, and then the probability of X occurring. And if it's the dice one, again, we list our sample space in the top. And underneath it, what's the probability of rolling a 1? 1 out of 6. What's the probability of rolling a 2? 1 out of 6. 1 out of 6. 1 out of 6. 1 out of 6. All right, they're obviously not always the same. But in this particular problem, every single one is a 1 in 6 chance, okay? All right, so a lot of board games involve rolling dice. Imagine rolling 2 fair 6-sided dice, one that's red and one that's green. Give a probability model for this chance process. Your probability model could just look like this, you guys. So we'll say this is the red dice, this is the green, and good old pre-algebra where you had to like do this 50,000 times. You guys remember that? It was like all the time. All right, so this is the sum of 2 dice, right? You roll a 1 and a 1 and you get a 2, etc., up to a 12. All right, and so our probability model is those are our possible outcomes. We could also calculate all of our probabilities now. So suppose we define event A as sum is 5. What's P of A? Probability of getting a 5. You're like, oh, I love pre-algebra. How many times do we get that? 4 out of 36. All right, and you can reduce it if you would like. You don't have to. Okay. Now consider event B. Sum is not 5. What'd you say? 32 out of 36. Everybody agree? Not a 5, so you just count up all the other ones, or do 1 minus, right? So it's 32 out of 36. And yes, you could reduce. Notice those add to 1. Wow. Okay. This is so great. You're like, I just want the homework and tests to be exactly like this. Okay. What is the probability that we get a sum of 5 or 6? All right. So if you have the word or, that always means add, okay, in probability. Or means add. So the probability of getting a 5 was 4 out of 36. All right. And we're going to add that to the probability of getting a 6. How many 6s do we have here? Looks like 5 of them. And we get our lovely answer. Okay. All right. A couple rules for probability. All possible outcomes together must have probabilities that add up to 1. All right. So if you're looking at a probability model, like the dice one, if you added up the 1, 6 plus the 1, 6 plus the 1, 6 plus 1, 6, right? All those up, you get 1. They will ask you to check if a probability model is legitimate. Okay, if they ask you to check, is this legitimate? Just add the probabilities up and see if they equal 1. That's all you have to do. All right. The probability that an event does not occur is always 1 minus the probability that the event does occur, right? So like probability of 5, probability of not 5 is just 1 minus that, okay? This is sometimes called the complement, you guys. All right, so if you haven't heard that word, you want to write down the complement rule. And so think of this little c right here as meaning not. So that's like the probability of not A, right, is 1 minus probability of A. Okay, if two events have no outcomes in common, the probability that one or the other occurs is the sum of their individual probabilities. So again, the or means add, but you are only allowed to add when the events are mutually exclusive. This is really important. I would write down mutually exclusive, okay? This is like a big concept for this chapter. So two events, A and B, are mutually exclusive if they have no outcomes in common, so they can never occur together. And you might add this little formula in because sometimes you'll see this, meaning the probability of A and B equals 0. And this and means like both at the same time. So if we're talking about a dice, you guys, the probability of rolling a 1 and the probability of rolling a 3, those are mutually exclusive, right? Even if I'm rolling 2 dice, the probability that your sum is 5 versus the probability that your sum is 6, those are mutually exclusive. There's no overlap. So you're like, what are we even talking about? We're talking about when you're drawing cards, okay? Think about a deck of cards. And I'm like, what's the probability of drawing a king or a club? Are those mutually exclusive? No. All right, they're not. Can you be both a king and a club at the same time? Yes. Okay, so you can only add probabilities together like this, where you just straight up add. You don't have to subtract anything when there's no overlap at all. So could I say the probability of a king plus a queen? Yes, because those are mutually exclusive. You can't be both a king and a queen at the same time in a deck of cards. But you can be a king and a diamond. So you kind of have to remember your card. If you're like, shoot, I don't know cards, you might want to like, we'll work on it, all right? Probably going to learn some cards, all right? So let's talk about if these are mutually exclusive. How about a king or an ace? Mutually exclusive? Yes. Okay, kings and aces are different cards. They're not a king and an ace at the same time. So yes, all right? Getting a white ball or a red ball from an urn of white and red balls. Are those mutually exclusive? Yes, you're one or the other. All right, it's white or red. So yes, those are mutually exclusive. All right, getting a number multiple of 3 and divisible by 2 when a dice is thrown. So let's think about a number multiple of 3. So here's our possible outcomes for when we throw a dice. All right, what's a multiple of 3, you guys? Okay, and how about divisible by 2? Yeah, so divisible by 2 would be the 2, the 4, and the 6. So are those events mutually exclusive? No, because of the 6, all right? The 6 has like both of those in common, all right? So no, not mutually exclusive. All right, oops. Drawing a red card or a jack from a deck of cards. Red card or jack, what do you think? Right, not mutually exclusive because you can be both a jack and red. How many jacks are in a deck of cards, you guys? 4. How many are red? 2, because half the deck's red, half the deck's black, right? So there's 2 reds and 2 blacks. Okay. Here's something that you might have for homework. So distance learning courses are rapidly gaining popularity among college students. Now we really know this, all right? Randomly select an undergrad student who's taking a distance learning course for credit and record the student's age. So there's their ages. This is called a probability model right here when you have a table, okay? So your outcomes are this, and here's the probability it occurs. Here's the outcome, probability occurs, et cetera, et cetera. Show that this is legit. How do you show it's legit? You add these up and you're like, yay, it equals 1. It might not. So if it doesn't, just say no. It's not legit, okay? All right. B, find the probability that a chosen student is not in the traditional college age group of 18 to 23 years old. So obviously, you guys, there's 2 ways to do this. Not in this age group. You could add up the 3 probabilities, or you could use the complement rule, right, and do 1 minus that probability to get your lovely answer. Now, we probably should do this, by the way, 18 to 23. And you can use the little complement thing if you want, not 18 to 23 years old. Everybody good with that? We probably should show our P-ofs on our homework, okay? Okay, choose an American adult at random. Define the 2 events. A, the person has a cholesterol level of 240 milligrams per deciliter of blood or above. So A means they have high cholesterol, you guys. They're over this amount. B is between 200 and 239, which is borderline high, all right? According to the American Heart Association, the probability of having high cholesterol is 16%, and borderline high is 29%. Why are A and B mutually exclusive, you guys? Yeah, you're one or the other, okay? You're either like over 240 or you're 200 to 239. You can't be both at the same time. They are mutually exclusive. I suppose you could also be less than that, hopefully. Some people could be. All right, but you can't be both at the same time. All right, say in plain language what the event A or B is. What does this mean? The probability of A or B. Luca, what do you think? Yep, one or the other. And when we do or in stats, what are we going to do? Add. Okay, so you're just going to add the probabilities. If you're either high or borderline high, there's a 45% chance of that occurring. Add them together. All right. Okay, if C is the event that the person chosen has normal cholesterol, meaning below 200, so they're adding that in, right? So anybody below, we're covering all our bases here. We have over 240, we have 200 to 239, now below 200. How could I calculate that probability? Bryce, what do you think?
You just do 1 minus the probability.
There you go. All right, everybody good? It's pretty basic probabilities today. All right, so here's your homework, and we're going to also do our worksheet 5.2a. So grab that guy. We'll start there, and then your homework. Okay, there's one more practice of simulation on here, just number 30, where you want to do the 10 trials, okay? These are all multiple choice and some easy probability, so I think you guys will be okay. It's not too bad.